I think I'll do one video for the last two topics because they're both types of applications of lines. So in this first topic, topic 5, we're going to talk again about parallel and perpendicular lines. So in a previous video, we talked about slope and we talked about what the slope means for parallel and perpendicular lines. So we knew that when you had parallel lines, they had the same slope. We also knew that when you had perpendicular lines, their slopes were opposite reciprocals. But when we're talking about actual lines, the parallel lines, there's an extra little piece to it that we haven't mentioned yet. So yes, two lines are parallel if they have the same slope, but there's an extra piece of information that you must know. They have to have different y-intercepts. If two lines have the same slope and the same y-intercept, they're just the same line, okay? So in order to be two unique, distinct parallel lines, you have to have the same slope, different y-intercepts. Now, parallel or perpendicular lines, it's the same thing. We just have to make sure they have opposite reciprocal slopes. So one slope has to be positive, one has to be negative, and then they have to be reciprocals of each other. So for example 7, it said, the directions say, determine if each pair of lines are parallel or perpendicular. Okay, or potentially neither. If you don't have any of these conditions met, then they're just two random lines hanging out in space. Okay, so for part A, we have L1 and we have L2. And this time, instead of just giving us 2 points on the line like they did when we were talking about slope, here we're given 2 equations of the line. So we want to determine the slope of each of these 2 lines using the equation and then compare the slopes. So the easiest way to get the slope here is just to solve for y. If we solve an equation for y, we get the slope and y-intercept for free. So looking at L1, I have 5x plus 2y is 7, okay? Now I want to solve that for y, so the first issue is the 5x. I want to subtract 5x from each side. That leaves me with 2y equals negative 5x plus 7. Hopefully we're going to get to the point where I don't have to explain every single step. You know, at the beginning I want to explain all those steps so you can kind of remember them and understand what's happening. But do remember that the x's cancel. We get lazy and say cancel, but it's because 5x minus 5x is 0. 0 plus 2y is 2y. And then I'm always going to write my x term before my constant on the right-hand side. Now I want to divide each term by 2. That undoes the multiplication. Undoes, is that a word? It will undo the multiplication of 2 and y. So here the 2's cancel to become 1. 1 times y is y. The x term, I just get negative 5 halves x. And then the constant's just going to be 7 halves. You could write it as 3.5 for the constant, but we'll just leave it as 7 halves. So here we have this equation. Let's look at L2. So for L2, we have 2x minus 5y equals 2. We want to isolate the y, so we're going to start by getting the term alone. I'm going to subtract 2x from each side. That leaves me with negative 5y equals negative 2x plus 2. I'm going to divide each side by negative 5. That'll undo the multiplication of negative 5 and y. So let's see what happens. We end up getting y equals positive 2/5 x minus 2/5. So let's look at those two slopes. So for L1, we had a slope of negative 5 over 2. For L2, we had a slope of positive 2/5. Well, right off the bat, one's positive and one's negative. They're definitely not the same slope. So we can say right off the bat, there's nothing parallel about these two lines. But so far, we have a positive and a negative. And if I look at 5 halves, the reciprocal of that is 2/5. So here we have opposite reciprocals. So that means these two lines are perpendicular. Okay. Now let's look at part B. So for part B, we're going to look at L1. So looking at L1, we have 3x minus 8y equals 16. I need to get the 8y term alone. I subtract 3x. 3x's become 0. That leaves me with negative 8y equals negative 3x plus 16. I now have to undo the multiplication of negative 8 and y, so I divide everything by negative 8. And that's going to leave me with y equals positive 3/8 x minus 2. So now let's look at L2. Same thing. So I've got 12x minus 32y equals 16. I'm going to get the y term alone by subtracting 12x first. That leaves me with negative 32y equals negative 12x plus 16. All right. I'm going to divide everything by negative 32. That'll undo the multiplication of y and its coefficient. 32's cancel to become 1. 1 times y is y. And now be careful here. We've got to do some simplifying. Looking at 12 and 32, they both have 4 in common, so we would divide them both by 4. I'll put little tiny 4s here. So negative 12 divided by 4, that would be 3. 38 divided by 4 would be 8. And then they're both negative, so that's going to be positive. So we get 3/8 x minus 1/2. So if we look at the slopes by themselves, the slope of L1 is 3/8. With a little work, we found that the slope of L2 was also 3/8. They are the same. So that means these two lines are parallel. Okay, so just know that yes, the slopes of the two lines matter. For lines to be parallel, they at least have to have the same slope. Just remember, they also have to have different y-intercepts. Perpendicular lines, it doesn't matter where they cross the y-axis at, they just have to have opposite reciprocal slopes. Okay, so that's the first type of application. The second one is a word problem. So let's look at this application. So we are told that for example 8, suppose the cost of manufacturing a cell phone is $50 per cell phone. That's important, so we're going to kind of highlight that. And the daily fixed cost is $5,000. So let's kind of break down what that means. We're going to have to go back to that idea of direct translation. We haven't done that in a little bit, but direct translation is the process of converting words to math. And when we're dealing with direct translation, we always have to assign variables. Okay, so there's kind of two things going on here. We have the cost of manufacturing just in general, and then we have the cost of just a single cell phone. Okay, so when we look at part A here, it says write a linear equation that relates the cost y to the number of cell phones manufactured x. Okay, so we're going to say y equals, that's the total cost. Y is going to equal $50 per cell phone that is manufactured in a given day. Okay, but we also have these daily fixed costs. So we have these two things happening, the cost of just manufacturing the cell phone and then daily fixed costs, things like rent, utilities, stuff like that. Okay, so we're going to say that the cost to manufacture these cell phones is going to be 50 times X. That's how much it costs per cell phone. So that's probably like the materials to actually make the cell phone. But for each day, there's an additional $5,000. So that would be our equation. The total cost for a day is $5,000 period, and then $50 for each cell phone that is manufactured. Okay. So what is the daily cost of manufacturing 600 cell phones? Well, we can easily take part A and we just replace X with 600. Okay, we know Y is the daily cost. X is the number of phones manufactured. So we would say, okay, Y equals 50 times 600. That's going to be the cost of just making the cell phones. But remember, there's also just fixed daily cost of 500. So let's see what we get. Let's go to the calculator. I hope I still have that up. I have Desmos up. Let's see. I can pull up the calculator here. So we want to take 50 times the 600. That's how many cell phones we were going to make. That's going to be $30,000. And then from there, it's pretty easy to add the 5,000. So let's go back to the worksheet. So we have that the daily costs are going to be the 30,000 to make the cell phones plus those additional 5,000 in daily fixed costs. So if we produce 600 cell phones in one day, the total daily costs would be $35,000. So this would be $35,000 to produce 600 cell phones in one day. Okay, remember, anytime you have a word problem, you need to describe your answer. Just briefly, it doesn't have to be like a paragraph, just a quick sentence, okay? Now, part C says, one day the total cost was $21,000. How many cell phones were manufactured? Well, this now represents the daily cost, which is Y. So we're going to replace Y with 21,000. That's going to equal 50X plus 5,000. And now we just want to solve for X. So the first thing I would do would be subtract 5,000 from each side. Well, I know that 21 minus 5 is 16. So 21,000 minus 5,000 is going to be 16,000. That's going to equal 50x. We can go back to the calculator really quick. So when I go to the calculator, I get 16,000 divided by 50, which is 320. Whoops, I forgot to share. There we go. So if I divide both sides of this equation by 50, the 50s with the x cancel, they just become 1. So x is going to equal 16,000 divided by 50, which we found to be 320. 320 what? 320 cell phones. So again, just make sure you describe your answer. So we were able from this basic sentence to create a formula that would represent daily cost based on X being the number of cell phones produced, because we know that it's going to cost $50 per cell phone, and then daily fixed costs are always 500. We can then use that formula to find daily costs if we know how many cell phones are produced, or if we know the daily cost, we can use that to determine how many cell phones could be produced. Okay, so this video we've covered a lot. Just remember the whole heart and soul of this was slope-intercept form of a line.